Okay, today we're going to do long division of polynomials, but before we talk about how to divide polynomials, we're also going to show how that is exactly really the same process as long division with numeric problems. So, for example, if you have 3025 divided by 13, the process for doing that division problem is identical in most ways to doing the polynomial long division. So the problem that you had in your book was x minus 3 as your divisor, 3x to the third minus 2x plus 5 was what you're dividing into. Now the only difference here at the beginning is that we actually have to notice that there's a missing power of x. So x to the second power isn't represented in what you're dividing into. So we actually have to insert 0x squared as a placeholder so that we have that represented in our division problem. Okay? So we do that automatically with numbers like the 0 we have over here, and we're used to doing that, but we're not really used to doing it with polynomials. But it is something you will need to do every time you have a long division problem, is start by checking to see if there are missing powers of x in between your terms, and then inserting 0 of those missing powers just as placeholders. And since you're adding 0 of them, you're not really changing the value of the polynomial itself. Okay, so that's just the initial setup, and now we can kind of ignore the original problem and just focus on what we have written here. Now, once you get to that point, the process is really very similar. So we know that in this original numeric problem, we would look at the first two digits, the 30, and we would see how many times 13 goes into 30. Well, 13 goes into 30 twice. And then we would multiply. 2 times 13 is 26. And then we would subtract. 30 minus 26 is 4. Well, we're going to do the exact same process over here as well. And that process, if you want to just remember like a mantra, it is divide, multiply, subtract. Okay, so divide, multiply, subtract. The same 3 steps will cycle over and over in these problems. Now, the division over here, you don't have to do 3x to the third plus 0x divided by x minus 3. It's not that complicated. You can just focus on the first term here, 3x to the third, and the first term here, x. So what is 3x to the third divided by x? Well, this x divided into that will just reduce the exponent by 1 power. So 3x to the third divided by x is 3x squared. So that's the divide. Then multiply. Well, 3x squared needs to be multiplied times x minus 3. So 3x squared times x is 3x to the third. 3x squared minus 3 is negative 9x squared. And then the next step is to do subtraction, just like what we did over here. Now over here we don't usually write the subtraction symbol, we just know that we have to subtract. But with polynomials, I find it to be beneficial to go ahead and do the written out subtracting work. Because we're dealing with more than one term, what that actually turns out to be is distributing a negative. So we distribute a negative, which means if we start with something that's positive, it turns into a negative. And if it starts off negative, it turns into a positive. Then we can simply combine the like terms that we see. So x to the thirds will cancel because we have a positive 3 here and a negative 3 here. And when we add the x squareds together, we get 9x squared. So let's repeat that procedure. Just like in this regular numeric problem, the next step is to pull down the next number. So in this case, we pull the 2 down, and then repeat. Divide, multiply, subtract. So 42 divided by 13 is 3. 3 times 13 is 39. 42 minus 39 is 3. So we divided, we multiplied, and then we subtracted. Same thing over here. So bring down the next term, which is a minus 2x, and then divide, multiply, and subtract. So 9x squared divided by x reduces the power of x. We get 9x. 9x times x minus 3. 9x times x is 9x squared. 9x times negative 3 is negative 27x. And now subtract, and in order to subtract with polynomials, I strongly recommend that you distribute a negative. Then you can just simply combine like terms. So the x squareds will cancel. Negative 2x plus 27x is a positive 25x. And now we have to do this cycle one more time. So again, bring down the next term, which in this numeric problem is a 5, and then divide, multiply, and subtract. So divide, 35 divided by 13 is 2, multiply, 2 times 13 is 26, and then finally subtract. 35 minus 26 is 9. Over here, bring down the next term, which is 5, and then divide, multiply, and subtract. So 25x divided by x is 25. Multiply. 25 times x minus 3 gives you 25x minus 75. And finally subtract by distributing your negative. So the x's will cancel, and 5 plus 75 is 80. Then when you express your answer, when you first learned regular division, you probably first started off by writing your answer as 232 remainder 9. And then when you become a little more advanced, maybe you learn that you can write it as a mixed number, where you have 232 and 9/13, 9 from the remainder and 13 from the divisor. Now, the same is true with polynomials, only most of the time we don't write the remainder just as a remainder, but you could. And there are some cases where that is beneficial. So you could write your answer as 3x squared plus 9x plus 25, remainder 80. But most textbooks, including yours, prefer it to be written, your remainder to be written as a fraction. So we'll do that. So the quotient, this 3x squared plus 9x plus 25, that part is all the same. And then just like how we got the fraction for 9/13, we do the same thing with our remainder here. The remainder becomes the numerator of the fraction, the top part of the fraction, and the denominator comes from the divisor, which in this case was x minus 3. And if you think about mixed numbers, it's really saying 232 and, or in other words, plus 9/13. So every time we have one of these remainder fractions tacked on, we have to make sure that we are adding that fraction. All right, so this is your final answer to the polynomial division problem, and hopefully that makes sense as to how we got that answer.